continuation of soil physical properties. So today I will be talking about aeration, color, temperature, and consistency. So soil aeration is the phenomenon of interchange of gases, especially oxygen, between the soil pore space and the atmosphere. So very important yung oxygen kasi it is directly involved in the respiration and very necessary for the proper functioning of roots and soil microorganisms. So here in this figure, you can see the average composition of soil air and the atmosphere or the pre-atmosphere above soil. So comparing to their gases content, so nitrogen in soil is higher compared to that of the atmosphere. So 79% yung atmosphere natin, yung free atmosphere, and 79.15% by volume yung nitrogen natin sa soil. Then oxygen is much higher in free atmosphere, which is 20.97 compared to that of the soil atmosphere, which is 20.60%. Then the carbon dioxide, in terms of carbon dioxide, the soil air is much more higher, which is 0.25% compared to that of the carbon dioxide content of the atmosphere. Okay. So what are the role of oxygen? Okay, if exchange of oxygen is restricted, there are some properties that may be affected. So root extension and uptake of nutrients and water by roots is limited. Arrest organic matter decomposition, so it can delay the organic matter decomposition. Limit the release of associated mineral nutrients. Then a reduction of iron, manganese, and sulfate to forms that are toxic to plants. So yung iron, manganese, and other elements, they may be formed in a reduced form, which is much more toxic dun sa ating mga halaman. So causes of poor aeration, bakit ba nagkakaroon ng poor aeration sa ating soil? So compaction of finer texture suffer from poor aeration. So that can be easily corrected by cultivation, of course, during our land preparation or tillage. Then also water logging. So once na na-stuck na yung water content sa soil natin, so syempre yung water, yung pore spaces na supposed to be air yung content niya, napapalitan ng water. So that's causes water logging. But that can easily be corrected by drainage. Then gaseous exchange between soil, air, and the atmosphere. So then we have two mechanism of gaseous exchange. Paano ba nagkakaroon ng palitan or ng exchange ng gases from the atmosphere at saka sa lupa? Okay, so we have what we call the mass flow and diffusion. So when we say mass flow, it can either be through wind, temperature, and or rainfall or water. So yung wind natin, of course, pagka nahanginan yung lupa natin, so there may forces, so barometric forces na magkakos na yung soil air natin is mapalitan ng air from the atmosphere. Then temperature. The soil temperature is higher than the atmospheric temperature at the midday when the soil gases expand and move out of the soil pore spaces into the atmosphere. Then the soil is cooler than the atmosphere during the night when the atmospheric gases enter the soil. So when during the day, yung soil air natin is much higher compared to the atmosphere. So magkakaroon ng exchange doon. That is similar during the night. Yung soil air naman natin ay mag-iba ng temperature, which is much cooler than the air in the atmosphere. So magkakaroon din doon ng exchange of gases. Then rainfall. So rainwater displaces soil gases in the pore space and carries gases which are dissolved in it to the soil. So yung pore space natin or yung soil air natin, once na nagkaroon ng rainfall or umulan, so yung water magpe-penetrate dun sa pore space. So ang mangyayari, mapapalitan ng water yung air sa soil. So once na nangyari yon, so napalitan na yung air sa soil. Then after matuyo, so after na ma-dehydrate yung soil natin, so papasok naman doon ngayon yung another air from the atmosphere. So magkakaroon ng exchange of air. Then another way na nagkakaroon ng exchange ng air sa soil air at saka sa atmosphere is through diffusion. So most of the gaseous interchange between the soil and the atmosphere takes place by diffusion. So karaniwan, ito yung nangyayari sa soil natin. Diffusion is the process by which each gas tends to move in the space occupied by another as determined by the partial pressure of each gas. So it's all about the concentration of gases. So the more na mas concentrated yung oxygen sa atmosphere, sa pre-atmosphere, then less oxygen ang meron tayo sa soil air. So maaaring yung ibang oxygen sa pre-atmosphere ay pumasok dun sa soil air natin. That's also similar to carbon dioxide. So as we all know, di ba, pagka meron tayong mga biological processes, yung mga microorganism natin, they respire. So pag nagre-respire sila, yung carbon dioxide content ay tumataas sa lupa. So means na nagkakaroon ng mas madaming concentration ng carbon dioxide sa soil air compared to the atmosphere. So magkakaroon din doon ng diffusion. So that's the two process how the soil is exchanged from the soil air to the atmosphere or vice versa. So aeration status of the soil. So how can we determine the soil erosion? So first is the percentage oxygen and carbon dioxide content. So yun yung by percentage, which ay nasabi ko na kanina, di ba, yung nitrogen, oxygen, and then the carbon dioxide. So then the next one is the oxygen diffusion rate. So it is measured by the diffusion rate, which is per gram per square centimeter per minute. So it determines the rate at which the oxygen should be supplied to the soil when it's being continuously used for the respiration of roots and soil microorganisms. The growth of roots diffusion rate decreases to about 20 by 10 to the negative 8 power grams per square centimeter per minute. So for most of the crops, the good oxygen diffusion rate is above 40 to the 10 to the negative 8 power gram per square centimeter per minute. Then another one to determine the status of the soil aeration is the oxygen reduction potential, or yung tinatawag dating redox potential. So it is measured by millivolts. So oxidation is the term to the process of gain or addition of electrons from another compound or ion or atom. Then reduction is the term given to the process of loss of or removal of electrons which are given to another compound, atom, or ion. So dyan nagkakaroon ng redox reaction. Like for example, di ba, pagka yung soil natin, when we say soil is in reduced condition, ibig sabihin siya ay saturated or waterlogged yung soil natin. Then once na dehydrate yung soil natin, doon na nagkakaroon ng oxidation process. So that can also be used to determine the status of soil aeration. So what are the different factors affecting soil erosion? This is the soil organic matter. So di ba alam natin na one of the characteristic of soil of organic matter is bulky. So bulky means mas madami siyang pore spaces. So it is good for aeration. Then soil structure. So soil structure, meron tayong mga structure like yung granular and crumb, which is best for pore spaces compared to the platy soil structure where yung permeability sa soil natin is nalilimit. Then we have soil texture. So sandy textured soil has large pore spaces compared to the fine textured soil. Then of course the soil moisture, because the pore spaces is actually divided into soil moisture and aeration. So once the soil moisture is is increasing, so the aeration of the soil or the soil air is decreasing. So what are the importance of soil aeration? So soil aeration affects the availability of some nutrient elements to plant roots. So manganese and iron occurs in a well-aerated soil in their higher valent forms. So yung manganese natin, kapag ka-aerated yung soil natin, they are present in manganese positive 4, manganese positive 3, and yung iron natin is present in iron positive 3. So these are actually good in plant roots. But if the soil is poorly aerated, so they are present in lower valent forms. So these are manganese positive 2 and iron positive 2. So they are available to plants only in their lower valent forms. Okay. Then carbon dioxide produced from the decomposition of organic matter reacts with water to form carbonic acid, which is slowly dissolved in soluble phosphate. So the availability of phosphates would be increased to the plant roots. So when carbon dioxide is higher in soil, so they are very reactive to water, which forms carbonic acid. Then yung carbonic acid na yon is nagre-react sa phosphate group, pinifix na yung phosphate group, kaya yung phosphate group is also affected, yung availability ng phosphorus natin sa lupa. So actually, carbon dioxide concentrations exceeding 15% are toxic to rice, but the concentration in paddy soils usually below this level. Then sulfur occurs as sulfate in well-aerated soil. So of course, we know that sulfate is available form of sulfur in soil. So it's very favorable siya kapag aerated yung soil natin. Organic matter is decomposed by aerobic bacteria in a well-aerated soil. Nitrates are reduced to oxides of nitrogen and nitrogen gases in poorly aerated soils. Roots get thicker, shorter, and darker in anaerobic soils that also retard the development of root hairs. So kapag hindi well aerated yung soil natin, yung plant roots natin tendency to become thick, short, and dark, which limits the growth of root hairs. So we all know that yung root hairs, yun yung responsible for nutrient absorption. Then some crops become infested with pathogens in poorly aerated soils. So next is the soil color. So soil color actually does not affect the behavior and use of soil. However, it can indicate the composition of the soil and give clues to the conditions that the soil is subjected to. So the soil color merely does not affect the crops, but it can indicate different properties na nakakaapekto sa crops natin. Okay? So we have in soil science, we have standard notation in identifying the color of the soil. So we use what we call the Mansell soil color book. So the Mansell soil color book has a standard notation using what we call the U, the value, and the chroma. So the U is the dominant spectral color. So dominant spectral color, which means yung ating Roy G. Biv, or yung red, yellow. So yun. Then we have the value, which dictates the degree of the lightness or darkness of color in relation to neutral grayscale. Then we have the chroma, which is the strength of the U, or the strength of the dominant spectral color. So here in this image, as you can observe, so ito yung isang page ng Mansell soil color chart natin. So yung 10YR dito sa upper right, so yan yung nagdi-dictate, yan yung tinatawag nating U. Okay? So that means 10 yellow red. Okay? Then the vertical, that is the value. So value, as you can observe, the lower the value, the darker the color of the soil. Then upon increasing the value, so the lighter the soil, which in contrast with the chroma, which is the strength of the U. So chroma is the yung horizontal natin numbers. So the more na tumataas yung chroma, the more naman na tumitingkad yung kulay niya. Okay? So for example, we have a value soil color of 10YR3/2. So 10YR, makikita natin yung 10YR na yon is ito siya. Okay? So ito yung 10YR, that's the U. Then the value is 3. So dito tayo titingin sa vertical numbers, vertically arranged numbers. So 3. So ito siya. Within this value. Then its chroma is 2. So 2, dito tayo sa horizontally arranged numbers. So ito siya. So ito yung means ito yung color ng soil natin. So sabi ko kanina, yung U natin is the dominant spectral color. So it ranges from yellow to the color of the rainbow. Okay, but the soil only according to Soil Mansell color book, only reflects the color yellow and red. Then the value, which 0, or the lower the value, the darker the color. Then the higher the value, the lighter the color. So the value can indicate the organic matter content of the soil. So if you will be asked if the value of the color is lower, does the organic matter content higher? So it may be the answer is true because it is darker. Because we all know that the darker the color of the soil, the higher the organic matter content. Then the chroma. So the chroma, the higher the chroma means the strength ng color niya. Okay, mas nakikita yung kulay, mas tumitingkad. So in Mansell color book, this is the different pages of the U. So it ranges from 10R to 10Y. So sa 10R, pag yung color ng soil natin is red, so we will start looking dito sa page na 10R. Then if the color is becoming yellow, so we are looking at the 10Y. Then habang bumababa yung yellow value niya, so pumupunta tayo sa 7.5Y to 5Y to 2.5Y. Then we have the 10YR. Then habang nagiging red, so 7.5YR, 5YR, 2.5YR, and then the 10R. So that's how we measure the U of the soil. So just to repeat, so the U or the dominant spectral color, so 10R is red, 2.5YR has some yellow, 7.5YR are tans and browns, 2.5Y is yellow. So in some color chart, so G is used also to represent green. So as soils age, they oxidize and change from yellow to brown to red. So karaniwan, di ba yung color is ginagamit natin sa soil profiling. So means na pag naging red yung color natin, they are in a latter stage na ng weathering process. So nalulus na yung mga basic cations kaya nagiging red na or nagiging acidic. Then the value, which is the relative darkness or lightness. So the lower the value, so from 1, which is the dark, to 8, light. The value is often a function of the amount of humic organic material in the soil. Darker soils have more organic material. So very black horizons may be buried charcoal or accumulation of manganese oxide. So the manganese is actually, yung color niya sa soil natin is dark. So minsan may makikita tayong mga dark concretions. So that can be a manganese concretion. Then whiter horizons may be the result of leaching, as in an E horizon. So yung E horizon natin, di ba yun yung tinatawag nating alluviated soil, wherein ang natitira na lang doon is yung mga light colored particles. Or the accumulation of carbonate or gypsum, which is also white in color. Then chroma. Chroma is the strength or the purity or intensity of the hue. So the color from 0, which is the least with none of the hue, which is the most vivid or yung most intense na color. This is indicative of the amount of pigmenting material present, but it is strongly influenced by the texture of the soil. Example, a soil color with 10 YR 5/6. So 10 YR is the hue, 5 is the value, and 6 is the chroma. So that's just another example. So what are the factors affecting the color of the soil? So parent material. So minerals relate to color. So of course, kung ano yung color ng parent material nila, they have somehow yun din yung color ng soil natin if it's not chemically weathered. Then through age and time, so older soil is often more red. So yun. Then climate, so may leach, remove coatings, or even enhance red. So in the form of again rainfall and also yung temperature natin, the peaks. Then topography, uplands are more brown and red, lowlands are more gray. So because we all know that somehow in lowlands mas dominant yung mga irrigated lands or yung mas naapektuhan ng water compared to the uplands na limited yung water nila. Then vegetation, conifers are more acid, more leaching, less color, and grasslands are more organic, darker colors. So if we can observe, diba, sa vegetation, if the crops na nagtathrive doon is annual crops, which means annually nagde-decompose na agad sila. So mas na dumadami yung organic matter doon. So mas nagiging darker yung color sa grasslands. So in interpreting soil color variation, so A horizon is usually darker than B horizon due to organic matter content. So di ba, we all know that the surface soil is actually the most fertile layer ng soil. So it is high in organic matter content. So A horizon is actually darker. Then dry soils generally have lighter color than moist soil. Then bright colors throughout the profile indicates well drainage. Gray or bluish green denotes anaerobic condition. So gray, di ba, minsan once we observe na waterlogged yung soil, grayish yung kulay ng lupa. So it because of the anaerobic condition. Then red soils are typically of tropical and subtropical areas, while dark gray and brown are typical of temperate regions. So dito sa Philippines, di ba, more on red soils ang meron tayo because of our climate, which is we are on the tropical climate. Then we have the soil temperature. So soil temperature is simply the measurement of the warmth in the soil. So soil temperature can be measured by different thermometer as follows. So we have the mercurial thermometer, or because of some restrictions, di ba, restricted na yung paggamit ng mercurial thermometer because of the mercury, which is highly toxic. So it can be alcohol or toluene thermometer. So this is the picture of the mercurial thermometer. So we commonly use this one to measure the soil temperature. Also, we commonly use the bimetallic thermometer. So this is a bimetallic thermometer. Then some use also the resistance thermometer. This is the picture, and the thermal scanner. So ito yung thermal scanner. So what are the different factors affecting soil temperature? So first one is the slope of the land or the aspect. So of course, 'di ba, yung minsan kapag higher elevated yung area, so elevation, mas cool yung climate. So mas malamig yung lupa natin. But in terms of aspect, 'di ba, kung saan nakaharap yung slope, then that is doon naka-direct yung sunlight. So ibig sabihin mas exposed siya sa sunlight. So the temperature there is much more higher. Then the climate. So of course the rainfall. So pagka umuulan, so it can cool down the soil, because we all know that water has a good specific heat. Ibig sabihin hindi siya madaling magbago ng temperature compared sa soil. So ma-absorb yung heat ng water sa lupa. So climate can affect the soil temperature. Then season, of course, during the dry season, mas hot yung soil natin compared to wet season. Then soil texture. Sandy soils in general warm up quickly than clay or fine textured soil, because fine textured soils carry a large amount of water, due to which they are slow to warm. Then soil structure. Granular and crumb structure warms up more rapidly because there is no water lagging. Soil color. Dark colored soil usually warm up more rapidly than light colored soil, as this soil absorbs more heat. Then vegetative cover. Bare soil warms up quickly and cools down rapidly. So pagka bare yung soil natin, madaling magbago yung temperature ng soil natin. So kapag sobrang mainit, due to sun, so tataas agad yung temperature ng soil natin. So biglang pag umulan naman or lumamig, so bababa agad yung temperature ng soil natin. But with the help of vegetative cover, so it acts as a buffer. So vegetation acts as insulating agents. It does not allow the soil to become either too hot during summer or too cold during winter. So pine-prevent niya yung extreme values ng temperature natin, yung vegetative cover. So importance of soil temperature. So germination of seed. For most plants, the optimum and maximum germination temperatures are actually 15 to 30 and 30 to 40 degrees Celsius respectively. So I think that can also be explained on your crop science, that how temperature affects the germination of seeds. With seeds put forth radical 6 days after sowing at 5 degrees centigrade, and 3 days at 10 degrees centigrade, and 2 days at 18 degrees centigrade. So just for example here on wheat, so as you can see here, at 18 degrees centigrade is a very good soil temperature, because it pinapagawa niyang mas maaga yung germination. Then plant growth also is affected by soil temperature. Most plant grows well in a temperature of 21.1 degrees centigrade to 26.6 degrees centigrade. No plant can survive below 4.4 degrees centigrade and above 48.4 degrees centigrade. Root elongation is very much dependent on soil temperature. Absorption of soil water. The maximum metabolic activities and maximum absorption of water by plant roots takes place generally between 20 degrees centigrade and 30 degrees centigrade soil temperature respectively. The availability of nutrients is also affected. The biological processes for the transformation and availability of nutrients are controlled by soil temperature and soil water. So at high temperature, di ba, minsan there are lots of nutrients that that's vaporized. So nagiging vapor form sila. So nawawala sila sa lupa. Of course, it is soil temperature affects soil microorganisms. Di ba meron tayong mga thermophilic bacteria or microorganisms na kailangan yung compost natin, di ba, mainit, kino-cover natin para mas mapabilis yung decomposition. So soil microorganism is also affected as well as decomposition of organic matter. Soil formation and other physical properties is also affected, and plant diseases. So how the soil temperature lost from the soil? So paano lumalamig yung lupa natin or umiinit? So first is through radiation. The same portion of temperature absorbed by surface soil is lost by radiation to the atmospheric environment. So when we say radiation, the heat of the soil is lost through electromagnetic waves. So yung heat na nare-release niya through electromagnetic waves, that is radiation. So the most common na change yung soil temperature natin is through conduction. So when we say conduction, the soil temperature is lost from the soil by the process of conduction, which means transmission of anything from one point to another. So pagka, like for example, yung soil natin is nagkaroon ng water, okay? So through conduction nagkakaroon ng heat transfer sa soil and water. So that's conduction. Then precipitation, especially during summer months, cools the soil by lowering its temperature. Evaporation also, the major portion of soil temperature is used for evaporation of soil moisture and transpiration of plant. So example is evapotranspiration. The evapotranspiration is a process by which soil moisture is lost from soil by evaporation and transpiration of plant. Then how we manage soil temperature? Paano pag sobrang init na nung soil natin? So this can be corrected by tillage. So the upper tilled surface has higher temperature than the underlying untilled soil. So kung pwedeng till natin, 'di ba, yung nasa underlying or subsoil is maibabaw para yung mainit na part is sa surface is lalamig. So that can be through tillage. Then mulching. So the use of mulches keep the surface of the land cool during the hot summer season and warmer in cold climate as it cuts off much of solar radiation. So this is very similar with the role of the vegetative cover. So through mulching, kung hindi mo tatamnan, so you can use a mulch. Then irrigation and drainage. So a portion of heat received from solar radiation is absorbed by soil water. So ito na yung sinasabi ko kanina. So soil water is very mas taas yung specific heat niya, which is 1 calories per gram kaysa sa soil. So mas pwedeng makatulong siya sa absorbance ng heat, yung soil water. Water-logged soil has a low temperature, and the temperature of such soil is possible to increase by removing excess water with providing suitable drainage. So pag mainit naman yung soil natin because of soil water, we can easily drain out the soil to cool down. Okay? The removal of excess water lowers its specific heat and increases the temperature of the soil. The specific heat of dry soil is actually 0.2 calories per gram, which is only about 1/5 of water, which is 1 calories per gram. And also, how we manage soil temperature is through the use of vegetation. As you can see here, at lower temperature, of course, at 0 degree water freezes. Then at optimum, sabi natin kanina, di ba 15 to 30 degree yung optimum soil temperature natin for plant growth or seed germination. So as you can see here, there is an optimum growth of different crops at this temperature. Then as the soil becomes bare or walang bed, walang cover, so the temperature is increasing. Then so at this level, most weed seeds killed in minutes, then up to the higher temperature. Okay? So yung soil temperature natin favors between this 10 degree to 30 degree centigrades. Not lower because the germination may be inhibit dito sa ating lower temperature, and not also above kasi pwede nang mamatay yung seeds natin. So it is commonly this one is the commonly the topic that is questioned in board exam, yung soil temperature regimes natin, which is used actually in soil taxonomy. So we have what we call the gelic temperature regime, which is too cold or virtually all crops. So the mean annual soil temperature is less than 0 degrees centigrade. So from the word gelic, diba? Cold, just like jelly sols, it represents low temperature or freeze or permanently froze soil because of the temperature of less than 0 degrees centigrade. Then we have the cryic, which is much mas mainit compared to gelic pero malamig pa din because of the mean annual soil temperature of less than 8 degrees centigrade, which also has a cold temperature in summer. Then we have the frigid, which is similar to cryic but warmer in summer. Okay. Then the mesic, which is the temperature which ranges from 8 to less than 15 degrees centigrade. We have the thermic soil temperature regime, which is ranges from 15 to less than 22 degrees centigrade. Then we have the hyperthermic, which is suited to citrus and other freeze-intolerant crops. We have this is the mean annual soil temperature is greater than 22 degrees centigrade. Then in some cases we use the prefix ISO to indicate that the mean annual soil temperature in summer and winter is less than 5 degrees centigrade. So this is used in isofrigid, as isomesic, isothermic, and isohyperthermic. Then we added the physical property, which is soil consistency in our discussion today. So soil consistency is designates the manifestation of the physical forces of cohesion and adhesion acting within the soil at various moisture content, including behavior towards gravity and pressure. So yung soil consistency natin, ito yung workability or yung manifestation ng soil water natin dun sa solids natin, sa sand, silt, and clay. Okay, so it is ang nagdidictate nito is yung tinatawag nating cohesion and adhesion. So ito it is one of the most important, makailang in our batch, makailang natanong tong part na to, tong cohesion and adhesion. So cohesion is the holding together, force holding a solid or liquid together owing to the attraction of like molecules. So pag parehas na molecules like sand to sand, so that is cohesion, or solid particles to solid particles is actually cohesion. Then with different molecules, the attraction of two different molecules is what we call adhesion. Like yung how water attracts soil solids, so that is adhesion, nag-a-adhere. So what are the different manifestations of soil consistency? So if the soil is saturated with water or in wet condition, we measure it by stickiness and plasticity. So stickiness is the quality of adhesion to other object. Then plasticity is the capability of being molded by the hands. Then we also have the friability and the softness when the soil is in moist condition. So the consistency between dry and the field moisture capacity. Then much more drier, we have the hardness or the harshness, which is consistency of soil air in air dry condition. So here, as you can see here, some field tests and terms used to describe the consistency and consistency of soil. So we have sa dry soil, we have the hardness, di ba? Hardness. So we have very hard, extremely hard, or loose. Sa moist soil, we have the test for friability. So we have the friable, very friable, loose, firm. So yan yung friability. Then we have on the inside, pag nasa field tayo, we measured the field penetration test using a pencil. So we have the very firm, hard, firm, medium firm, and soft soil. So that's how we measure soil consistency. Actually, there is a later on I will discuss this one. So first is the factors affecting soil consistency. So ano ba yung mga nakaka-apekto sa soil consistency natin? Of course, texture. Diba? The more the soil is clayey, the more it is plastic and sticky. Then the organic matter content, then the mineralogy or yung mga montmorillonite natin, kung type of clay, so kung elite, kung kaolinite, so that also affects the consistency of the soil. So we have what we call the Atterberg limits of soil consistency. So it is one of the how to measure soil consistency in laboratory. So this is a Casa Grande device. So it is done by Arthur Casagrande. So actually the principle of Atterberg's limits is by Albert Atterberg, which is further defined by Arthur Casagrande. So during this device, so yan, papaikot mo yan, then yung baol, malalagyan mo ng sample ng soil, then hahatiin mo using the grooving tool, magkakaroon ka dyan ng line. Then habang pinapaikot mo yan, parang ito ay bumababa, tumataas. So bibiglangin mo yung nitong device na to. So that's how you done the soil consistency measure. So yan, habang tumataas yung ating water content, as you can see here in this figure, water content, tumataas yung water content, meron tayong tinatawag na liquid limit kapag yung soil natin is mataas yung water content. Then we have the plastic limit kapag mas kakaunti yung moisture compared to liquid limit. Then the shrinkage limit, which is pag mababa yung soil moisture natin. That's how you measure the soil consistency of the soil through Atterberg's limits. So meron tayong shrinkage limit kapag dry soil, plastic limit kapag moist yung soil or mas madami yung water content, then we have liquid limit kapag saturated yung soil natin. So what are the importance of the soil consistency to agriculture? So friable consistency presents the optimum condition for tillage and preparation of seedbed. So di ba pagka unless rice yung rice paddy yung gagawin natin dun sa field natin. So pag vegetable, di ba sa upland, ano yung consistency ng soil na gusto natin? Of course, kapag very dry yung soil, yung nasa hardness siya. Okay, pag very dry, ayaw natin kasi napakatigas ng lupa. It's hard to land prep. Ang gusto natin is yung nasa friable stage or yung nasa lower limit to field capacity ng moisture natin. Doon madaling i-cultivate yung soil natin or i-till. Then at the sticky point, encourage compaction due to formation of dense layer. Of course, kapag sticky yung ating yung soil, so it's very hard to land prep. because of formation of the dense layer or yung matigas na layer or yung compacted.